Hi everyone, we're going to use our knowledge of index laws to do some simplifying of fractional indices. Here you can see the questions we're going to look at. You can attempt these yourselves right now if you pause the video. Otherwise, you can work through them with me now. Okay, first up, we're going to write these exponential expressions in surd form. Surd is the British English word. American English would say radical form. Okay, 15 to the power of a half is square root of 15, and that's really the definition that we're working with. Okay, m to the 1/4 is the fourth root of m. Okay, the important thing here with 7 to the 2/5 is that 2/5 is 2 times 1/5, or 1/5 times 2. So if you remember that, you'll find this easy. So the fifth, so it's the fifth root of 7 squared. If you want to simplify that, you may. It's the fifth root of 49. If you look at the difference in these two expressions, this is the square root of 7 to the power of 5. So you can see that the numerator is the power that it's raised to, and the denominator is the root. Right, in index form, so this is the opposite of what we just did. Index form and exponential form. Okay, so square root of t is t to the half. Cube root of 5 is 5 to the 1/3. And here it's the fourth root, so the 4 is in the denominator. So that's 6 to the power of 9 over 4. And same here, we'll get x to the power 6 over 7. Okay, this is a slightly higher example here because we have three things going on. The 1, the 5, the 2. First thing you got to remember is 1 over is the same as raising it to the power of -1. Okay, and then what's inside the brackets here is the same as these examples up here. So it's the fifth root makes the power 1/5. The squared makes the power of 2/5. And then when you raise a power to another power, you've got to multiply those exponents together. So that's your final answer. G to the power of -2/5. Okay, so we can use these basic definitions we've seen on the last 2 pages to help us do this without a calculator evaluate. Okay, 8 to the 2/3. So that's 8 to the 1/3 times 2, or to the power of 2, because 2/3 is 1/3 times 2. 8 to the power 1/3 is the cube root of 8, and you'll remember that 8 is 2 cubed, so that's 2. So 2 squared. And 2 squared, you know, is 4. Just to get you thinking, I could have done that. Okay, because 2 times 1/3 is 1/3 times 2 is 2/3. So this is also adequate, but I didn't do that because 8 squared is 64, and the cube root of 64, I don't know off the top of my head. Now I know it's 4, but I didn't necessarily know that a second ago. Okay, so you're going to pick the one that's easiest. So here I could go 25 to the power of 3 to the power of a half, or more logically, I'd go 25 to the power of a half to the 3. Because I don't know what 25 cubed is, but I do know that 25 to the half is the square root of 25 is 5. So we've got 5 cubed, and then I can quickly do 5 times 5, 25 times 5, 125. Okay, this time we got 27. No idea about 27 squared, and we've got a negative here too. So let's break it down simply. 27 to the 1/3. I know 27 is 9 times 3. That's 3 times 3 times 3. That's 3 cubed. 27 to the 1/3 is 3. And that's 3 to the negative 2. Well, negative means 1 over. So it's 1 over 3 to the 2, and that's 1/9. Alternatively, you could have added this extra step here and make 3 to the negative 2 into 3 to the 2 to the negative 1 and gone that way rather than this step here. Okay, last one. 36 to the 1.5. 1.5 isn't very much help to us. Let's make it a fraction. 3 over 2. Okay, 36 cubed, no idea. Let's do 36 to the power of half to the power of 3. 36 to the power of a half, I know, is 6. 6 cubed is 36 times 6. Quickly in my head, I can work that out to be 216. Okay, and that's how you simplify fractional indices. Okay, so those are our answers. You can check your answers, and good luck with your continuing questions. Bye for now.